Memory Analysis 1. Memory data is binary data. At first glance, you cannot tell which data is from which file. And since there is not much research on memory, research on structure is insufficient. We did not know the structure, so we mainly analyzed the memory by searching the entire memory data. Also, since we did not have a lot of time to extract important data from memory when we were searching for a string, this analysis helped us to solve an accident or an incident. String search mainly used email addresses, passwords, and file names as search parameters. A file carving technique was also used to retrieve and extract file signatures for known files, graphic files, HTML files, registry, and event logs from memory. Initially, there was no analytical methodology and only fragmentary analysis was conducted on binary data. However, since the memory structure has been researched for about 85% at present, we started analyzing the memory based on the object storing the specific data rather than the string search. By analyzing the object, it is possible to extract the necessary data accurately in the memory, and it is possible to grasp the next analysis step. Let's look at the lecture materials. First, the process that is in memory is selected according to the analysis purpose. Since the selected process also has a unique area such as virtual memory, the data that it executes and uses is likely to remain in physical memory. By extracting the process memory area and performing string search or file carving, you can obtain more accurate data. If the selected process is suspected to be malicious code can be scanned. If it is determined as malicious code, analysis of the registry and driver usage can be used to analyze most of the problems in memory. Depending on the case, the analytical methodology will be slightly different, but in larger frames, the analysis will follow the order in the lecture material. The object-oriented analysis methodology was described earlier. So, how do you find objects in memory? There are two typical ways to search for objects. The two methods are list working and pattern matching. Let's look at each method from now on. Let's start with the list walking method. Do you remember the annular dual-linked list I described earlier? An annular double-linked list is a typical list working method. A circular doubly linked list traced the object using PS-active process head. In addition to this, you can track objects using elements such as CSRSS, PSP-CID table, sessions, and handles. For a description of each element, please refer to the lecture materials. To summarize, the list working method is a method of finding objects by using information of other objects that the object has. Let's look at pattern matching. Pattern matching differs from list working in that objects do not utilize the information they have. I mentioned earlier that using the PS-active process head method among the list working methods can hide the process using the DKOM method. Pattern matching is a method designed to find hidden processes due to DKOM. The idea of pattern matching is that the structure of the object has a pattern. Pattern matching is to scan the memory data from the beginning to the end with the pattern, extract matching data, and analyze the data to check the process list. If you scan from the beginning to the end of the memory data, you can also find the processes hidden by list working. After all, there is a hidden process somewhere in the memory data. Another important thing is that you can find hidden processes as well as processes that have already been terminated. When a process terminates, the objects in the process remain in memory. The object of the terminated process is also different from the object of the running process and can be found by pattern matching. Let's look at the pattern criteria defined by the pattern matching method. Both processes and threads exist in memory as objects. These objects contain a data structure called object header and a data structure called dispatcher header as the underlying data structure for synchronization. Processes and threads are also important objects in memory. Therefore, the object contains a data structure called pool header to avoid paging. By searching for objects that meet these criteria and interpreting the object data, you can find processes and threads in memory. It is almost impossible for a person to do the above-described analysis by hand, especially when analyzing large amounts of memory data. So, based on the studied memory structure, a memory analysis tool that can easily analyze the memory has begun to be developed. The most popular memory analysis tool is volatility, followed by recal. The advantage and disadvantages of each tool will be covered in each tooltip. In addition to the volatility and recal tools, there are quite a few memory analysis tools. The picture you see now is the execution screen of memory analysis tool called Redline. It is a memory analysis tool created by Mandiant Corporation for analysis of infringement. This tool has the advantage of being easy to use. In addition, it is easy to identify malicious code by using IOC data structure. IOC is a data structure that summarizes the characteristics of malicious code. It also supports memory data collection. There are many features that are good for the analyst to use, but the downside is that they are slow due to many features, and analysis is less expensive than other memory analysis tools. This time, I will introduce the Volatility tool. Volatility is an open-source memory analysis tool. You can download the latest version of Volatility from GitHub. The functions of Volatility are all in the form of plugins. You can create your own plugins and add them to Volatility. Every year, the plugin contest allows you to upgrade plugins to the full version. It has more analysis functions than other memory analysis tools and supports memory analysis of Windows, Linux, and Mac operating systems as well. It is good learning to check the usage beforehand by clicking on the link of volatility usage in the lecture materials which we are watching now. The memory analysis exercise will be conducted using volatility, so I will explain how to use volatility simply. As mentioned earlier, volatility comes as a plugin for all features. When analyzing, it is necessary to specify the operating system of the memory file. This is called a profile in volatility. If you want to see a list of plugins offered by volatility, you can use the Check Plugin List option. The provided plugins may have options per plugin. To check plugin-specific options, just type in the plugin name you want to check, then enter the Help option. I have organized the plugins provided by Volatility into categories. First is the process list. We have created a plugin that finds a list of processes using list working, pattern matching, and so on. Note that the plugin created based on list work is a plugin called PS List. The plugin based on pattern matching is PS Scan. In addition, the PS Tree plugin is a plugin that shows the process list as a tree. List working is the method of finding a process when it is implemented as a tree. In addition, the process uses multiple files when it is running. You can use a plugin such as DLL list, handles, etc. to view information such as files used by processes. You can also check the network information in memory. There are 4 plugins that analyze network information. However, each plugin is used differently depending on the operating system. Connections, sockets, and ConScan plugins are used when the memory file is Windows XP 2003. If you use the plugin on Windows 7 or later, the analysis will not work properly. The NetScan plugin is only available if the memory file is Windows Vista or later. You can then extract the process to memory as a file and store it locally. The common feature of these plugins is that the word dump goes into the plugin. Typically, you use the proc.exe dump plugin and the proc.mem dump plugin. The proc.exe dump plugin is a plugin that extracts processes running in memory as exe executable files. However, it does not extract it as a perfect exe and it does not execute. The proc.mem dump plugin is a plugin that extracts the memory area used by the process into a single file. The Proc MEM Dump plugin allows you to see at a glance which areas of memory the process was using. Volatility also provides basic malware detection plugins called MalFind. The plugin uses the permissions of the memory area to determine if the process is malicious. Analyst judgments are important because results include false results. You can also extract information such as the commands you have typed in the command prompt window that we frequently use, services running on the current operating system, and so on. I explained that memory is divided into kernel area and user area. Volatility also supports kernel area analysis. The kernel area is mainly used by rootkit malicious code and carefully crafted malicious code. Therefore, when analyzing the malicious code, if you analyze the memory, you need to look at the kernel area too. Some kernel objects have files and associated objects. A plugin called FileScan is a plugin that finds and analyzes objects related to files. When you use the plugin, you can see a list of files loaded into memory. You can also check the registry in memory. The registry is a file that the Windows operating system always uses. Therefore, it is always loaded in memory. Volatility provides a plugin that allows you to locate and analyze the registry loaded in memory. There is a plugin that enables you to analyze the registry directly from a plugin that extracts specific data. And it is likely that the user's password or decryption key is stored in memory. Volatility also provides plugins that find this important information in memory. So far, we have looked at a number of plugins offered by Volatility. There are a lot of plugins available, but it's not easy to use them. Understanding the output of each plugin requires a deeper understanding of memory. And Volatility does not support analysis of large memory files. I did not consider large memory files when designing the tool. Also, because it is a plug-in type, the speed is very slow. To overcome these shortcomings, the Google Forensics team created a tool called Recall. Recall is a Python, open-source tool like Volatility, focusing on mass memory analysis and speed improvement, which was a disadvantage in Volatility. Development is still underway. However, there are not many features that are supported compared to Volatility as they are late participants. However, I think it is convenient to use it after replacing Volatility because it is similar in its usage. So, it is best to analyze Volatility and Recall tools at the present time. Let's analyze the memory using various knowledge and tools described above. The file used for memory analysis is the memory file that was used for the HoneyNet 2010 Forensic Challenge contest. The scenario is simple. An unusual activity has been found in a bank account of a company, and you want to analyze the memory file of the employee's PC that was managing the account. These are scenario-related issues. Let's solve some problems now. Memory file analysis proceeds with the Volatility tool. The first step in analyzing the memory is to determine the source of the memory file you are trying to analyze. We need to signal to the analysis tool which operating system the memory file was obtained. Volatility provides the Image Info plugin as a plugin that checks the profile of the memory file. When you run the Image Info plugin, it gives you an approximate range of the operating system on which the memory file was obtained. We can select one of the suggested operating system profiles to use for memory analysis. You can use it with the Profile option. This is a note. The results of the Image Info plugin we saw earlier were defined as not correct. In Windows XP, you can choose the profile more precisely. For Windows XP Service Pack 2, the xpsp2res.dll file exists. If you are looking for the existence of the file in memory, the memory file is the Windows XP Service Pack 2 operating system. The first problem is to find a process that seems to have been involved in the initial attack. To see the list of processes, use the PS List plugin by default. If you think about the scenario, you said that you received a PDF file by email. Nowadays, we send malicious code into PDF file. You can view the acrord32.exe process by browsing the process list for the process associated with the PDF file. The process is a viewer process that allows you to read PDF files. This time, we will look at other processes related to the acrord32.exe process. Using the PS3 plugin, you can see results like in lecture material, so you can easily understand the correlation of processes. The parent process of the acrord32.exe process is the firefox.exe process. The firefox.exe process is a Firefox web browser. The acrord32.exe process was opened in the Firefox web browser because the webmail was able to open the PDF file as an attachment by opening it directly or automatically opening the PDF file in the Firefox web browser. Therefore, the answer is firefox.exe acrord32.exe process. The second problem. This time, it is a matter of looking for a socket that is open to suspicious processes. You can think of a socket as a kind of connection device used in a network. Then you need to analyze the network information in memory. Network analysis differs according to the Windows operating system as described above. The currently analyzed memory file is a Windows XP version, so you can use the Connections plugin. In the analysis result, local address is the IP assigned by the operating system of the currently analyzed memory file, and remote address is IP somewhere connected with the analysis target. The PID is the ID of the process responsible for the connection. If you search the internet for the remote address IP that firefox.exe and acrord32.exe process are connecting to, you can see that it is the IP assigned to Israel and Iran. In addition to the currently analyzed firefox.exe and acrord32.exe processes, the svchost.exe process is also a process related to malicious code. It is not a complete malicious code, but a malicious code injected into a normal process. This is a fact that will be revealed in the future problem, FYI. You can also check the Sockets plugin. This time, let's collect URLs that appear to be malicious. Malicious URLs will be used by malicious processes. What the process uses is stored in the process memory area. So, you can extract the process memory area and look for the URL. There are two ways to extract the process memory area: the proc MEM dump plugin and the MEM dump plugin. The two plugins differ slightly depending on the implementation method and the process memory extraction method. I will explain the difference and method later, and this time let's use MEM dump plugin. The MEM dump plugin has an option to specify the PID input option and save path for the extraction file as plugin's own options. Please refer to lecture material for example. When the process memory area is extracted to a file, it looks for the URL through a string search. In the lecture, we used a mixture of strings and find str as a string search. The keyword used the HTTP character, which is common to the beginning of the URL, as the keyword. The sort command shown in the lecture is a command that sorts strings. It is not an essential command. We have extracted the URLs in the same way as described above and organized only the suspicious URLs. Since the usually known URLs have domain names, the URLs with the IP names should be suspected. Other URLs should be checked if they are similar to normal URLs. These are the URLs you are currently looking at. This is a problem about file carving. After extracting the process memory area, carve the known files for the process memory area. We use the Foremost tool in the lecture material. The Foremost tool carries files on a signature basis. It is also the most popular carving tool. The results of the carving are marked on the lecture materials. When looking at the carved files, several files can be seen, but there is also index.dat file. This file is an Internet web history file. If you analyze it further, you can see the results of the next page of lecture materials. The analyzed results show URLs that are similar or identical to those found in the process memory area. I will finish this lecture with this problem. This time, the goal is to find files related to the attack. If it is a normal file, it is thought to be stored in the hard disk, and file system forensics is carried out. However, you can extract files from memory or check the list. There are many ways to do this. But in this case, we'll use the FileScan plugin. With the FileScan plugin, you need to filter out all the resulting output. Now that we are looking for files related to malicious code, we'll use the exe keyword, which is an extension of the executable file. Among the results that are filtered, make sure that the name is abnormal or that there is a known name for the malicious code. If you check several files together with Internet search, you can find files that are organized in lecture materials.